All right, guys, we're going to get started on chapter 3. So let me present my screen and we'll start. Okay, so in this chapter, we're going to be studying quadratic equations and functions and graphing and solving. So to start with vocabulary, quadratic equations are equations that are nonlinear and can be written in the standard form ax squared plus bx plus c equals 0, where a cannot equal 0. It must have an x squared. That's why a can't equal 0. If a was to equal 0, there would be no x squared, and then it wouldn't be quadratic, it would be linear. So the fact that this has an x squared and this equation has an x squared, that's what is a dead giveaway that it is a quadratic equation. It's okay if the bx term is missing. It's okay if the c is missing. Okay, if either one of those is 0, that's okay, but it has to have an x squared term. Notice that neither one of these equations is set equal to 0, and you're going to see in a minute that you may have to set the equations equal to 0 and then start working with them. Then we have zeros of a function and roots of an equation. The zeros of a function are the x values for the function for which f of x equals 0. Basically, that's saying where y is equal to 0. They're the x-intercepts of the graph. So when we look at the graph, the x-intercepts are the zeros of the function, okay? The roots of the equations are the solutions of the equations. In all honesty, we use these terms interchangeably. The roots of an equation, the zeros of a function, all right? We're going to solve by graphing, by square rooting, and by factoring. Today, we're just going to be looking at graphing and square rooting, then we'll move on to factoring. So to get started, we have this quadratic equation, 0 equals x squared minus 9, and we're going to solve by graphing. And just to be consistent with how we graphed in the last chapter, I'm going to look at this as a standard form equation. So let me get my pen. Okay. So if I wrote it in standard form, because as you can see, it's missing that bx term. It has an x squared and it has a constant, but it's missing the bx. So if I was to write it, I would write it as 0 equals x squared plus 0x, just as a placeholder, right, I guess I'm going to be writing with my mouse today because my pen does not want to cooperate. So 0 equals x squared plus 0x minus 9, okay? And then we can list the values of a, b, and c. Let's see if my pen wants to work now. So a is equal to 1, b is equal to 0, and c is equal to -9. All right, I know that this is my y-intercept. We talked about that in the last chapter. And I know that the a value tells me it's opening up and there's no vertical stretch or shrink. All right, to find the vertex, I'm going to use x is equal to -b over 2a. So it's 0 over 2 times 1, which is just a 0. And then to find the y, I'm going to write the equation. Instead of a 0, I'm going to turn that into a y. Y is equal to, and you're going to plug 0 in for the x's. So y is equal to 0 squared plus 0 times 0. Guys, I'm not scribbling. My pen is just doing whatever it wants. So just ignore it for a second while it calms down. Let's see if I can clean some of that up. All right. So 0 times 0. I'm just going to leave that mess there, and then -9. Okay, so that all mess, maybe I'll just scribble it out since it already was. That all just comes out to a 0. So you have y is equal to -9. So now I know my vertex is at 0, -9. Okay, so I'm going to plot that point. which will be down here. All right. And then since there's no vertical stretch or shrink, I can use that parent function pattern, out one, up one, plot a point, out one, up one, plot a point. Then it's out two, up four, 1, 2, 3, 4, plot a point, out two, up four, 1, 2, 3, 4. Then it's out three, square three to get 9. So it's going to be all the way up here. Out three, up 9. Get rid of that. Out 3, up 9. All right. And you want to keep graphing until you hit the x-axis, which is where I am now. All right. And then I can draw my parabola. Ooh, try to hit the points if you can. All right. And your x-intercepts are here, which that is x is equal to positive 3, right? 1, 2, 3. And here, which that point is x is equal to negative 3. X is equal to negative 3. So your two solutions are the two answers for this problem. The two roots, the two zeros, are x is equal to 3. Oh my dear goodness. X is equal to 3, and x is equal to negative 3. I just want to write the last answer, negative 3. Okay, there we go. All right, let me erase that mess and we'll move down to the next one. Same idea here. So I'm going to start by writing the equation, setting the equation equal to 0. All right, in order to do that, I'm going to move the 4x squared and the negative 4 over. Let me write it out first. 8x equals negative 4 minus 4x squared. So I'm going to move the 4x squared over by adding it. Move the 4x squared over by adding it. So now I have 4x squared plus 8x equals negative 4. Then move the 4 over, the negative 4 over by adding. So now I have 4x squared plus 8x plus 4. Right? My A value is a 4. My B value is an 8. My C value is a 4. To get your vertex, you do x equals negative b over 2a. So I have negative 8 over 2 times 4. It's going to give you negative 8 over 8, which is going to equal negative 1. To find the y value, you write y equals 4, and then you're going to replace, my pen's being weird. You're going to replace all the x's with a negative 1. So 4 negative 1 squared plus 8 times negative 1 plus 4. So that's going to be 4 times 1 minus 8 minus 8 plus 4. So that's 4 minus 8 plus 4. It's negative. So it's negative 4 plus 4, which gives you a 0. Okay, so now I know my vertex is at negative 1, 0. So I'm going to plot that point. So negative 1, 0 is right. Oh, no, it's not. Negative 1, 0 is right here. Right. Let's see if my pen wants to work for this part. All right. And then the A value tells me that it's opening up and it has a vertical stretch of 4. So I'm going to go out 1 and then up 4 times as many as I normally go. I normally go up 1, so 4 times that would be up 4. 1, 2, 3, 4, which makes sense because my y-intercept should be a positive 4 since my C value is a positive 4. and then it's out 1, up 4. You don't have to keep going because, again, what we're looking for are the x-intercepts. Where does the parabola cross the x-axis? It crosses, it touches the x-axis right here, where x is equal to -1. So there is one answer for this problem, and it is x is equal to -1. X is equal to -1. Okay? All right, let's move on to the last graphing problem. Okay. So I'm going to rewrite this equation, and then I'm going to set it equal to 0. All right, so I'm going to set it equal to 0 by, again, moving the x squared and the 4x over by adding. So when I do that, I'm going to have plus x squared plus 4x, bring it to the other side, plus x squared plus 4x. So I have x squared plus 4x plus 7 equals 0. So your a value is 1, means it opens up and it does not have a vertical stretch or shrink. My b value is 4. My c value, which is your y-intercept, is 7. Okay. Your vertex, you can find x equals, come on. X equals -b over 2a. So I have 4 over 2 times 1. It's 4 over 2, which is just a 2. To find your y value, you're going to write this function down, but replace the 0 with a y. So that is going to be y is equal to, replace the x's with 2's, 2 squared plus 4 times plus 4 times 2 plus 7. That's going to give you 4 plus 8 plus 7. That's going to give you 12. Oh, did I lose a negative sign? Did I lose a negative sign somewhere? Oh, I did up here. Sorry, guys. I have to back up just a bit. With my messy pen, I lost a negative. All right. Got to go back a little bit. It's -b, so that's I lost the negative on the 4. -4 times 1, that's -4 divided by 2, that's -2. Okay, so I was plugging in the wrong value. I was plugging in a positive 2. So I'm going to have y is equal to -2 squared plus 4 times -2 plus 7. So that's going to be a positive 4 minus 8 plus 7. So that's going to be at -4 plus 7, which is going to give you a positive 3. Positive 3. Wherever my pen might be, okay? So now you know your vertex is at -2, 3. So I'm going to go -2, 1, 2, 3. That's my vertex. And since the a value is a 1, that means my graph opens up and there's no vertical stretch or shrink. So I'm going to go out 1, up 1, out 1, up 1. Then I would go out 2, up 4. And then I would go out 2, up 4. Okay, as you can see, this parabola sits up here. And is it ever going to cross the x-axis? No. So that means that there are no real solutions. No real solutions. So if your parabola doesn't cross the x-axis, All right, there are no real roots. We're going to talk about imaginary roots later on, but for now, you can answer the question by saying there's no real roots. All right. Okay, let's clear that. Let's move down. So the next four, solving by square roots. These are, if you take a look, actually, let's look at all four, or three of them for a second. T squared equals 400. All right, here we have 2k plus 3 squared minus 19 equals 81. And here I have 1 7 p squared equals 5 7 p squared minus 20. Okay, and there's something similar about all of them. It might not be as obvious right at the get-go, but let's solve number 4 first. When your variable has a square next to it and is isolated, in order to get the t completely by itself, the inverse operation of squaring something is taking the square root. All right, so you're going to take the square root of both sides of that equation, and let me write it out. Oop, oop, oop. Okay, so I'm going to have at some point my pen will want to work for me, maybe not. Let me just write it with my mouse then. Okay, so it's t squared equals 400. To get t by itself, you take the square root of both sides and you have to do plus minus. So it's going to be the square root of t squared is equal to plus minus the square root of 400. Okay. The square root and the square cancel. So you're left with t is equal to plus minus, and the square root of 400 is 20. So you have two answers. You have t is equal to a positive 20. That would be one root of this function, and t is equal to negative 20. Okay. The reason you have to do plus minus is because there are two numbers. If you think back at the original equation, if you plug in a positive 20 squared is equal to 400. If you plug in a negative 20 squared is also 400. Okay, so that's why the plus minus is necessary when you're taking the square root of both sides of an equation. Okay. So the second problem, we're going to isolate the part of the equation that has a square root as much as possible. So I want to get this part by itself. So in order to get that part by itself, I'm going to add 19 to both sides. Okay, so nope, still not going to work. Thought my pen might want to work for me, but it doesn't. All right, so I'm going to add 19 to both sides. So plus 19, plus 19. And I have 2k plus 3 squared is equal to 100. So 100. Okay. All right. So then what you're going to do, just like the last problem, to undo a square, I have to take the square root. So I'm going to take the square root of 2k plus 3 squared. And when I take the square root of the other side, I must remember the plus minus. So plus minus the square root of 100. Right? The square root and the square cancel. So now you're left with 2k plus 3 equals plus minus 10. At this point, you have to write two equations. You have to write 2k plus 3 is equal to positive 10 and 2k plus 3 is equal to negative 10. So over here, I'm going to write 2k plus 3 is equal to 10. And then down a little bit, I'm going to have 2k plus 3 is equal to negative 10. And you have to solve both of those. All right. So I'm going to subtract 3 from both sides. So I have 2k is equal to 7. And I'm going to divide both sides by 2. So I have k is equal to 7/2. That's one of my answers. All right. And then I'm going to subtract 3 from both sides here. It's going to give me a negative 13. So I have 2k is equal to negative 13. And then divide both sides by 2. And you're left with k is equal to negative 13 over 2. And that's my other answer. All right. And the last problem. All right, so for this last problem, we're going to solve for p. All right, so we want to get p by itself. I see p squared on both the right and the left. I could subtract the 5/7 p to the left or subtract the 1/7 p squared to the right. But if I did that, if I move this to the right, I then have to move the 20 to the left, which would be fine. It just depends on if you want to keep everything positive or not. All right, so I'm going to subtract 5/7 p squared from both sides. That's a 5/7 minus 5/7 p squared. They're like terms, that's why I'm combining them. So 1/7 minus 5/7 is negative 4/7 p squared equals negative 20. Right? Then I'm going to multiply both sides by the reciprocal of the fraction. So I'm going to multiply the left-hand side and the right-hand side by negative 7/4. Negative 7/4. Multiplying negative 7/4 by negative 4/7, that's just a positive 1. Now I have p squared equals, and negative times a negative is a positive. I can cross simplify. 4 goes into 4 once, 4 goes into 25 times. So you're just multiplying 5 times 20 to get a 35. And the very last step is to take the square roots of both sides of the equation. Just don't forget your plus minus in front of that 35. All right, the square root cancels with the square. So you're left with p is equal to plus minus root 35. Okay, there are no perfect square factors of 35, so it can't be simplified. And if I don't ask for a decimal approximation, you give your answer as a simplified radical because that is the exact answer. All right. So that is the lesson for today. Sorry, my pen wasn't working. You had to deal with me writing with my mouse. That's not very fun. But we'll catch up again for the next lesson, which will be the end of lesson 3.1. Bye.